This is a new rule for us, the sums and differences of two cubes. So I've written our two rules here in green. We'll refer back to them as we work through a couple of examples. So for number 2, I have a problem in the form a cubed plus b cubed. So this is the sum of two cubes because we've got a plus here in the middle. So in my first set of brackets, I need to take the cubed root of the first term and add it to the cubed root of the second term. So the cubed root of x cubed is x, and the cubed root of 27 is 3. And the rule says I need to have a plus in the middle there. Now in my second bracket I'm going to have 3 terms. The first term will be the first term in that first set of brackets squared. So we get x squared. The next term is going to be negative. That's just part of the rule, and you can check how that works by expansion. And we find that by multiplying the first term and the second term together. So x times 3 gives me 3x. And then the last term in this set of brackets is that second term from the first set of brackets squared. So 3 squared is 9. Probably the hardest bit of these is getting your signs mixed up. So when you first start out, just take that really carefully. For question number 6. Again, this is a sum of two cubes. So in my first set of brackets, I take the cube root of the first term, the cube root of 8 is 2, and I add that with the cube root of the second term. The cube root of the second term is 3y, because the cubed root of 27 is 3, and the cubed root of y is y. In my second set of brackets, I take that first term from the first set of brackets and I square it, so I get 4. Remember, in the sum of two cubes, the second term in that second set of brackets is negative, and then we multiply together those two terms, so 2 times 3y gives me 6y. The final term is found by squaring the last term in the first set of brackets. So 3 squared gives me 9, and y squared gives me y squared, so I get 9y squared as my final term there. Okay, have a look at this next one. This one looks a little more difficult than it is. You just need to take care and you'll find you'll need a few sets of brackets. So the cubed root of this first term, x plus 1 all cubed, is just x plus 1. The brackets may not make a difference, but it's always a good idea to use them just in case. Now this is a difference of two cubes because we have a negative in the middle. So my next term will be the cubed root of y, cubed, which is y. So that's my first set of brackets. Now in my second set of brackets, I square this first term. So I get x plus 1 all squared. I leave that as it is for now, and we can tidy that up on the next line. Now all of these in this second set of brackets are positive for a difference of two cubes. The second term we get by multiplying together the first and the second term from the first set of brackets. So I've got x plus 1 times y, and then my final term is found by adding the square of that last term from that first set of brackets, which is y squared. Nearly forgot to square it. Now in the next line I'm going to tidy up by expanding a little bit, and in this first set of brackets I can actually take that x plus 1 out of brackets. Oops. Apologies, I closed my brackets a little too early. I get x plus 1 minus y, and then in my second set of brackets, if I use my special product to expand x plus 1 all squared, I get x squared plus 2x plus 1. Of course you can do that by FOIL, but you might find that takes a little longer. And then this is y times x, so I get xy, and then y times positive 1 gives me positive y. Remember, that's just expanding brackets using the distributive law, plus a y squared on the end. And I'm going to put that all in square brackets and then see if I can do any tidying up on the last line. So my first set of brackets, x plus 1 minus y, and then that second set of brackets, I'll just look to see if there's any like terms. In actual fact, there's not. So that second bracket is going to be a little messy. We get x squared plus 2x plus 1 plus xy plus y plus y squared. So I could really have finished at that line above there, but I'd made things a little bit messy. Doesn't hurt to check. So I hope that's helpful for expanding our sums and differences of two cubes.